Vectors are used to mathematically represent the world around us. If you have done a 5 kilometer run today, you are representing the distance that you have done using this number 5. Such quantities, which you can measure using a single number, these are called as scalar quantities. If you want to capture the distances that you have run throughout the week, maybe you have ran 1 kilometer on day 1, 2 kilometers on day 2, and so on, and 5 kilometer on day 5. These distances can be represented as a n by 1 dimensional vector, where n represents the number of runs that you have made, and 1 represents the measurement that you have made, which is distance in kilometers. Graphical format, this is how it looks like. The distances that you have measured, these are just points on a number line, where the number line represents the distance in kilometers and each point represents the measurement that you have made. However, not everything in this world can be represented using a single number. Most of the things in this world are complex and needs multiple measurements to describe them. For example, if you bought a house and you are describing that house to a friend, just mentioning that you bought a two-room house is not enough to describe the house to your friend. Maybe you want to add other characteristics of the house, say the age of the house, a two-room house which is 5 years old. Now here, the number 2 and number 5 independently by themselves are scalar quantities. 2 represents the number of rooms, which is a scalar quantity, and 5 represents the number of years, that is the age of the house, which is again a scalar quantity. But in order to represent the house as a whole, you want to combine these two scalar quantities and therefore represent this house as a vector 2 comma 5, where 2 represents the number of rooms and 5 represents the age. Therefore, you can think of a vector as a combination of multiple scalars, where each scalar represents the magnitude or the number of units in a specific dimension. So when you are describing this house, you are saying that the house is 2 units of magnitude in number of rooms direction and 5 units of magnitude in the age direction. Now when you have multiple such houses, you can represent them as a n by 2 dimensional array, where n represents the number of houses and 2 represents the measurements that you have made, that is the number of rooms and then the age. And if you want to represent this graphically, then each house represented by the number of rooms, say the rooms is the x-axis and age is the y-axis, then each house becomes a point in a two-dimensional space represented by the rooms axis and the age axis. And if I draw a line from the origin to each house, basically what I'm saying is that this particular house is x units in the rooms dimension and y units in the age direction. Similarly, you might want to add other characteristics of the house. Maybe the size of the house. In that case, you'll represent the house as a three-dimensional vector, where the first dimension represents the number of rooms, second dimension represents the age of the house, and third dimension represents maybe the size of the house in square feet. Now each house is represented in 3 dimensions. When you look at it in a graphical format, each house becomes a point in a three-dimensional space represented by number of rooms, age, and the size. And as I said earlier, here each house will then be represented by x units in the number of rooms direction, y units in the age direction, and z units in the size direction. Now, what is the use of representing these data in the vector format? Now, as you can see here, I can easily differentiate between the houses by figuring out which houses are similar to each other and probably maybe should price similarly, and which houses are very different to each other and maybe should be priced differently. For example, these two houses are very close to each other and therefore they are more similar than say this house and this house. Also, representing any data set in a vectorial format makes it very easy for us to apply mathematical functions on it using linear algebra, and which makes it computationally very efficient.